Well, a warm welcome to anyone joining. Thank you for being here. Get yourself ready with a notebook, a pencil, or a pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today we have yet another quick SAT problem. This is a multiple choice problem. Focusing on parabolas. And we're asked a very SAT-like thing. We're not just asked for one quantity. We're asked for how many times greater is one quantity, it's the maximum height, than the width of this arch. So we have an arch which is built in a parabolic shape. So go ahead and give yourself, about a minute and a half, maybe two if you need it, but the faster the better. Try to figure this out for yourself. You can pause the video and give yourself a minute to do that. Then when you're ready, come on back and I'll show you how to do it. Okay, so without further ado, we have a quadratic equation, of course, whose graph is the shape of a parabola. And I think we're supposed to assume, on the SAT, you need to assume things once in a while. I think we need to assume that the width of the arch is referring to the width along the x-axis. Since technically this parabola is going to continue going downwards forever, the equation would dictate that anyways. I think we're going to use reality to sort of limit that extension. We're going to use reality to say, well, there's some distance along this portion that's going to be considered the width. I guess we can treat 0 as sort of like the ground. So what you're going to want to do is you're going to want to compare the maximum height, which really is sort of like the y value of the vertex, and we're going to compare that to the width of the arch, which is essentially going to be the distance between the X-Intercepts. Okay, so that should make sense. Now, what we need to do is get an idea of where these things are. So first, let's take a look at this quadratic and let's graph it, which is done in many different ways potentially, but because there's no y-intercept, I actually know that the parabola will be touching this origin point. It'll have an x-intercept of 0, and we'll factor to see what else we really get here. So let's take out negative 3x. If this is equal to 0, let's take out negative 3x, and we're left with x minus 8. So that means that our two intercepts are x equals 0 and x equals 8. So there's the other one. I'll just put it here arbitrarily. And so the width along the base is a distance of 8. The vertex, of course, is going to occur halfway through. I don't even know if that's half, but let's just say that's half at x equals 4. And we can determine the height by simply plugging in 4. So remember, we get to use the fact that these parabolas are symmetric and a quadratic function has symmetry. Since we have 2 points on the parabola at the same height, these are the x-intercepts, they're at the height of 0, I know that the vertex must happen directly in between. Let's find out how high up it goes. It's probably not going to be drawn to scale very well. Let's plug in x equals 4 to find out what the y value must be. The y value must be negative 3 times 4 squared plus 24 times 4. So quite large numbers here. We're going to have negative 3 times 16, which is negative 48. And then we get double of that, which is 96, leaving us with a positive 48. So definitely not drawn to scale, but that's okay. We can use numerical labeling to insist that this is y equals 48. I insist. And we have a parabola which goes like that. It would definitely go very steep if I had drawn it to scale, but you'll notice how these extra parts don't matter. We just care about this width, and we just care about this height. So let's reveal some of the answer choices here. Well, of course, 48 is not there. 8 is there as the width, but we don't want the width or the height. We want how many times greater is the height than the width. So we're going to have 48 as the height divided by 8, which is the width, and that just gives us 6. Okay, so it took a couple minutes to break that down, but I wanted to do it carefully. The quick way, a summary of what we did basically, would be to just find the distance between the x-intercepts however you need to, find the height of the vertex however you need to. You also could have used negative b over 2a to find the middle. That would have been negative 24 over negative 6. It still gives you that x value of 4. And then you just need to carefully use the question, which asks for how many times greater the maximum height is than the width. Other than that, pretty straightforward. If you get good at these, it should only take you about 45 seconds to a minute, although you technically have about a minute and 30 seconds on the SAT. Okay, I think that's enough blab out of me. I'll catch you guys next time.